All right, so today we're going to go over 3.4 notes, which is the remainder and factor theorems. So remainder says if a polynomial function f of x is divided by x minus c, then the remainder is f of c. So meaning if we did like synthetic division, whatever the remainder is the same thing as if we plugged it into the equation. Synthetic division is used to evaluate the functions called synthetic substitution when we do this. So this is what we were practicing yesterday. So this time is what I said at the very end of yesterday's notes. You're using the number this time. They're telling you -3 works. So, or that -3 is what you want to divide by, not that it works. So it's asking you to evaluate. So really it's saying, what is f of -3? So one way to find out what f of -3 is to do synthetic division. Some people, you could plug in -3. I'm not going to lie. If you plug in -3 into x and hit equals in your calculator, our remainder is the answer out of your calculator. This is a way, though, to do that, to plug in -3 and never need your calculator. So let's have a little fun. So bring down your 1, multiply and add down. Let's see, -15. Where did I mess up? Oh, it's positive. Yeah, -3. Oh, because I looked at the wrong number. Sorry. It's a long day. I should need to stop making videos today. So -20 is our remainder. So f of -3 equals -20. So I already have number 1 ready. I put the 1 on the outside. Number 2 ready. I have the 1 on the outside. The number's on the inside. So we're going to go ahead and add down, multiply up. So this tells me that f of 1 equals 11. Try again. Put the -2 on the outside. See that we're missing the x squared term. So multiply, add. So this tells me that f of -2 equals -5. So I don't have to grab any kind of calculator, and I can tell you, plugging in -2, exactly what do I get out of that function. 5, 4, 3, 2, 1, 0. I like to count down if you heard me. Count down my exponents, make sure I didn't miss any of them. So then f of 4 equals -12, 4. Okay, so then our last one down here says a number of tickets sold during the Oakdale high school football season can be modeled by this function where x is the number of tickets sold. Find the number of tickets sold during the 7th game of the season. So we're going to plug in 7, and then it'll tell us how many tickets were sold during the 7th game of the season. So we could just do 7 like this instead of actually grabbing a calculator and figuring it out. So f of 7 equals 229. Turn your papers over onto the back. And now this is the factor theorem. So given a polynomial f of x, it's a factor if and only if the function equals 0, or meaning that we have no remainder. So this is called our factor theorem. So use the factor theorem to determine which polynomials are factors on each one. So what you would need to do on these is we're going to put a -1 on the outside, and we're just going to synthetically divide this. We're going to put a 5 on the outside, and we'll synthetically divide. And then we're going to put -6 out here, and we're going to synthetically divide. If the remainder ends up being 0, then we know that it factors. So let's go ahead and do this one. That remainder is not 0, so that one does not work. That one was a remainder of 0, so we're going to say this is a factor. So x minus 5 is a factor of that. down here, sorry, this one also came out as a factor 0, so this one also works. So very good. So let's go ahead and try some of these down here then. So put your 2 on your outside. 3, 2, 1, 0. So your constant term is 0 this time, so make sure you put a 0 there. Though it shouldn't really matter, because if you get 0, you're going to end up getting 0. These numbers are really big, so I'm about to grab a calculator because I don't multiply that fast in my head. So, just in case I need it. So that's 2. Oh wait, this is a 1 here. That becomes a 2. -4. -50 gives me -28. I'll be positive because 78 is bigger. So we end up with 0. So this one is a factor. So let's check -4 here. I don't know. So let's see. So we get 23. So that gave me 0. So -4 is indeed a factor. So multiply. Oh my lord, that got big quick. I can tell you right now, this sucker is not going to be a factor. Oh yeah, that's even way too big. So it's negative like 2, 5, 3, 8, 2. So that's definitely not a factor. So only the first and the last ones were factors. And then we're going to actually use the factor theorem down here to solve these. Let's see. So we're going to completely factor and give the 0. So this is what we were practicing yesterday on the other set of notes. So we'll put a -3 out here. This actually factored originally, so I wouldn't have used this theorem. I would have just grouped these in the original, and if you can group them, go right ahead and do that too. You don't have to do this. This is just if you didn't see that it works or not. So this gives me x squared minus 4. Don't forget the original. If we're factoring completely, though, this factors into x plus 2, x minus 2. Don't forget that. X plus 3. So that's what f of x equals. That's our function. And then to get all our zeros, we plus or minus 2 and -3 here. All right, over here, put a -2 on the outside. 3, 4, 3, 2, 1, 0. Good, we got 0. So if this doesn't factor for us, we'd have to find another 0. So this is x cubed, x squared, x number. I can tell that I'm going to be able to group these right here, but if they didn't, you'd have to have found another 0 besides just the 2 right here. So this right here, I can pull out a 9x squared, and I can pull out a -1. Don't forget your original factor term. And then this factors again because it's a difference of squares, so x minus 3, x plus 3, x minus 4, x plus 2. So that's right there. So to find all your zeros, we get plus or minus 1/3, 4, and -2 are all of our zeros.